The first four examples from these sections here were pretty straightforward, just the adding, subtracting, and multiplying. Now, the remaining ones get into factoring, okay? And really, factoring is essentially the reverse of multiplying, right? When you multiply, you take two factors and write them as a sum of terms, whereas with factoring, you're actually taking a sum of terms and writing it as two or more factors. Okay, so it's really the reverse of multiplication. And the first, most simple form of factoring is factoring using the greatest common monomial factor. All right. So what is the greatest common monomial factor? It's really just the, in parentheses, biggest, right? Because biggest, doesn't really have a meaning here when you're dealing with variables, but it's the biggest monomial that divides evenly, and that's the key. It has to divide evenly into each term of the original polynomial that you're trying to factor. Okay, so you first have to identify the GCF in any factoring problem, if there is a GCF. So in this case here, example 5, 20b cubed plus 25b squared. So what you've got to do is you've got to say, all right, well, it's really two pieces. What's the biggest number first that'll go into both 20 and 25? Well, the biggest number that'll go into both 20 and 25, right? The greatest common factor of 20 and 25 is 5. Okay? And then you have to ask yourself, well, what's the biggest power of b that will divide evenly into b squared and b cubed? So, well, b will go into all of them, right? B will divide evenly into both of them, but actually b squared will divide evenly into both of them as well. Now, b cubed would divide into b cubed, but it wouldn't divide into b squared. So what ends up happening is when you're trying to find the greatest common factor, it's always going to be the lowest power of each variable that you see there. So in this case, I only have b's, and the lowest power of b is actually the second power. So that's actually going to be my GCF there, 5b squared, right? So I always take out the lowest power of the variable that I see. Okay, so 5b to the second is my GCF, so that becomes my first factor. And then what I'm going to do is I'm going to open up a parenthesis for my second factor, because what my second factor is going to be is what's left after I divide the original polynomial by the GCF. Okay, so when I divide 20b cubed by 5b squared, you've got to remember to subtract exponents, right? So 20 over 5 is 4, and b to the third over b divided by b squared is really b to the 3 minus 2, so it's b. And then 25b squared over 5b, 25 over 5 is 5, and b squared over b squared, it cancels out. Or you can look at it like it's b to the 0, which is just 1. Okay, so this is the factored form of that expression, right? 5b squared was the GCF, and then 4b plus 5 is my second factor, which is left after dividing. Okay, and then I'm going to do the same thing in example 6, the difference being I have 3 terms now. So I still have to treat it in steps though, right? In this case, it's actually 3 steps, right? It's the numbers, the x's, and the y's. So remember what we did. What's the biggest number that will divide into 15, 10, and 25? And again, in this case, it's 5, right? So 5 will go into 15, 10, and 25. What's the highest power of x that will go into x squared, x, and x squared? And again, what do? You take the lowest power that you see. So it's x. And then what's the biggest power of y that will go into y, y, and y squared? Again, lowest power that you see is y. So 5xy is the GCF in this case. So that's my first factor. And then now I'm going to open up a parenthesis. And now what's going to be left? I'm actually going to have 3 terms, right? Because I started with 3 terms, so my parenthesis is going to have 3 terms. So 15x squared divided by x squared y divided by 5xy is going to be 3x. 10xy divided by 5xy is just going to be 2. And then negative 25x squared y squared divided by 5xy is going to be negative 5xy. Alright? So that's my factored form. 5xy times the quantity 3x plus 2 minus 5xy. So that's factoring by the GCF.